Hello students, we're now going to begin a set of video lectures on the Earth cycles, of how the matter and energy associated with planet Earth is in constant motion. Now we'll first begin by an overview or a review of our dear planet Earth. The Earth is a sphere. It has a radius of 6,378 kilometers. Now, to give you some perspective, the distance between, in the United States, between California and Maine is about 4,000 kilometers. So it's about 1.5 times that distance is to the center of the Earth, to the Earth's crust. The Earth's crust is about 10 to 100 kilometers in depth. If you look at the right, you see an analogy of a slice of pizza, and the crust of the Earth being analogous to the crust of the pizza. So it's a very thin crust pizza, our planet Earth, about 10 to 100 kilometers, and that's only 0.1% of the radius of the Earth. So the crust of the Earth is more like the skin on an apple, a very thin skin which we walk upon and carry out our daily lives. As we discussed in a recent chapter, there are about 20 continental and oceanic tectonic plates that are sort of floating around, which comprise the Earth's crust. What is very distinctive about planet Earth is that about 72% of its crust is covered by oceans. And let's consider the deviations in the Earth's crust. We have mountains as high as Mount Everest, which are about 8.85 kilometers, or about 9 kilometers above sea level. And then the deepest depths of the Earth's crust, the Marianas Trench, which is in the western Pacific, close to the Philippines, is about 10.9 kilometers below sea level. So you can see there can be variations of almost plus 10 kilometers and almost minus 10 kilometers from sea level for these features of the crust of the Earth. The Earth also has a thin atmosphere that goes up to 50, maybe 100 kilometers. We'll see in the next slide, it's probably closer to 50 kilometers. This atmosphere of gases is held close to the crust by gravity. If you look again at our slice of Earth pizza, and we start at the bottom, the tip of the slice, we have a solid core that is made primarily of iron. It is under very high temperature and pressure, but the pressure is so high that we think that it is a solid core. And then we have an outer core where the very high temperature, we think, causes the material, mostly iron again, to be liquefied. Then we have two regions that are called the mantle, the lower mantle and the upper mantle. Where the material is somewhat in between solid and liquid, we have magma, which is liquefied under high temperature and pressure, but some of the material is probably more solid-like. And near the top, we have the lithosphere, the crust, and the upper mantle. And this is where we have our tectonic plates. Other features of planet Earth is that it rotates on an axis with a period of 24 hours, and of course it revolves around the sun with a period of 1 Earth year. The average distance of the Earth from the sun is 150 million kilometers, and that's a number that's so large that it's hard to have any perspective. But let's also point out that it takes light from the sun 500 seconds, and you know light travels as fast as is possible, that it takes light 500 seconds to travel from the sun to the Earth. So that's like what, 8 minutes and 20 seconds? Think about that. So if the sun had exploded, it would take 8 minutes for us to have noticed it on planet Earth. That's how far away the sun is. Now, we talked about the atmosphere, that the Earth has a thin atmosphere of gases. And I said it can go up to maybe 100 kilometers, maybe it's better to say it's up to 50 kilometers. If you look to the left in this slide, we have the various regions of the atmosphere. First, we have the troposphere, which is the lowest layer of the atmosphere, up to maybe 20 kilometers. Here we have mountains, and this is where airplanes fly. Then above that, we have the stratosphere, where maybe weather balloons and maybe some supersonic jets can fly in the stratosphere. That goes up to about 50 kilometers. Above that, we have the mesosphere, and that's really where meteors die. And above that, we have the thermosphere and then the exosphere. And really, we're talking about space at that point when you go that high. That's where the shuttle flies. To the right, you see a similar diagram showing the Earth and how the troposphere can go up to maybe, in this depiction, up to 18 kilometers. Then we have the stratosphere and the mesosphere, etc. It's interesting to note what is called the ozone layer, which is at the upper part of the stratosphere. You've probably heard of the ozone layer, how it's important in protecting us from ultraviolet light from the sun. So most of the gases in our atmosphere actually are within the first 20 to 50 kilometers. It's because gravity pulls down the gases in our atmosphere, and it really thins out as you go up higher. We measure the amount of gases in our atmosphere using a concept of pressure. We talk about the pressure at sea level. Why at sea level? Because that's where we are, and we make the measurements at sea level. But we say the pressure can be 1 atmosphere, that's a term that we use quite often, or 1.013 bars, which is essentially the same as 1 atmosphere. Or we may describe the pressure in terms of pounds per square inch, PSI, and we might say it's 14.7 pounds per square inch. Or we might say it's 29.92 inches of mercury. These are different ways of measuring atmospheric pressure. And in the next slide, I'll explain a little bit more about what this means. But let's first talk about the composition of our atmosphere on planet Earth. It's made mostly of nitrogen, the gas nitrogen. 78% is nitrogen, followed by 21% being oxygen. And then notice a big drop into 1% of argon, and then much, much smaller amounts of all the other gases that exist in the atmosphere, including carbon dioxide, 0.04%. The one gas that's quite variable is water vapor, and we refer to that as in terms of humidity, and it can vary a great deal, but on average it's about 1% of the composition of the gases in our atmosphere. Finally, let me draw your attention to another photograph taken from outer space showing the atmosphere as a very thin blue line on the surface of the Earth. So if the crust is like the skin on an apple in terms of its thickness, the atmosphere is then maybe like a very fine layer of dew on this apple. Very, very thin. So what do we really mean when we talk about pressure of air? Well, imagine having a long column going up maybe 50 kilometers that is 1 square inch, and that's about 1 square inch. That's about 1 square inch in diameter, and have this long tube or long column going as high as possible, maybe 50 kilometers. The air inside of that column would weigh 14.7 pounds. You get the connection? 14.7 pounds per square inch. That would be the weight of the gases in the atmosphere. Now, of course, the gases thin out as you go higher. But if you added it up, it would be 14.7 pounds. And that essentially is the weight of the atmosphere that is pressing down on you. It's like a bowling ball per square inch. Now, we don't really feel that pressure on our heads because the air pressure is pushing in all directions around us.
Deep greens and blues,
Deep greens and blues are the colors I choose.
Won't you let me go
A song by James Taylor, which I think aptly describes our dear planet Earth. Deep green and blue. What are some of the key characteristics of planet Earth? Why talk about key characteristics? Because when we're always fascinated about whether or not there could be life on other parts of the universe. And we always then try to compare any other planet or moon that might be discovered with planet Earth to see if we think there are key characteristics that might sustain life. Well, planet Earth is made of 34.5% or about 35% iron. Now, most of that iron is in the core of the Earth, as we mentioned earlier. Well, we're made of a lot of iron. But the next most abundant element in planet Earth is oxygen. Nearly 30% of Earth is oxygen. Next, at about 15%, we have silicon and then magnesium. Now, with silicon, think of all the sand. That's silicon dioxide. Another key characteristic of planet Earth is that we have so much water, but it's also liquid water instead of solid water, ice, or just gaseous forms of water. Now, imagine if you're from some other universe and you happen to notice this little planet, the third planet from the sun, and you notice that it has liquid water. What does this tell you? Since you know that water is a solid below 0 degrees centigrade and is a gas above 100 degrees centigrade, it tells you that the average surface temperature must be between 0 degrees centigrade and 100 degrees centigrade. And it turns out that the average surface temperature of planet Earth is about 14 degrees. So water will be in its liquid phase state on planet Earth. Now that turns out to be very, very important for sustaining life and for other things such as lubricating the plates for plate tectonics. You will also notice that there is an atmosphere. You can see clouds, so there must be gases. And that would tell you that there must be sufficient gravity to hold the gases in place as an atmosphere around this planet. The fact that there is free oxygen is probably the most striking feature that you would notice, because oxygen is prevalent throughout the universe, but mostly it would be found as oxides of other elements, especially metals. So we see a lot of metal oxides, oxides of silicon, and oxides of magnesium and iron, etc. in planet Earth. But we also have a lot of free oxygen in our atmosphere, and that would be a clue. Again, if you're an investigator from some distant universe, that would be a clue that something is going on in planet Earth, and that something, as we'll talk about later, is photosynthesis. Another important feature of planet Earth is that it has a magnetic field. What's important about that is that deflects cosmic radiation, which is important to protect us from bombardment of charged particles from space. Because the Earth rotates with a 24-hour period, that leads to cycles of day and night, which may be important for the development of life. The tilt of the rotation of the Earth, the tilt on its axis, leads to seasons. Planet Earth has a moon, and that moon produces tides. And also the plate tectonics produces various geological features. Now, going back to the fact that most of the water on planet Earth is in a liquid form and that the average surface temperature is about 14 degrees, that must mean that Earth is in a habitable zone around its sun. That is sometimes called the Goldilocks zone. If Earth were much closer to the sun, like Mercury and Venus, it would be too hot. If it were further away, it might be too cold. So planet Earth is at a distance that is just right, the Goldilocks zone, to possibly sustain life. Now we're going to pause, have a little quiz, and then we'll continue and talk about Earth cycles. See you shortly.